What is up, everybody? Welcome to the 17th lecture of Contemporary Math. Today we're going to be talking about annuities, the math of buying a home, of buying cars, and of credit cards. To start off with, I thought we'd start with annuities. An annuity, it's like that scene in Finding Nemo, an annuity is, by definition, just a series of equal payments taken out over equal intervals of time. So one place we see annuities show up is with retirement plans, like an IRA, an individual retirement account. And when calculating the value of an annuity on an account that's collecting compounding interest over n periods of time, we calculate that amount using this formula. So we've got the amount is equal to whatever our payment is for each period in a year. So that amount, that principal amount, times the quantity of 1 plus r over n, all raised to the n times t power, this quantity plus 1, all of that divided by r over n. Okay, so what is all of this? Well, like I've already said, P is the monthly or yearly or weekly, however you break up the time frame. It's the payment that you're putting in at every period. R is the annual interest rate. N is the number of periods that you're paying within a year. So if you're paying monthly, that's 12 periods, N would be 12. And again, A is the amount that gets paid at the end. By the time all this is done and set for, A is that amount. And of course, T is time, measured in years. So, let's see how we're going to use this. As an example of when we might use this formula, let's consider this problem behind me. What we've got is a person who's paying into an IRA for 40 years. They're paying into it once a year, $3,000. They're doing this, like I said, for 40 years. And it has an interest rate of 8%. What we want to find out now is, at the end of those 40 years, how much money this person's going to have in their IRA, as well as how much of that is going to be from interest. Well, to start, we need to identify which values belong to which of these variables, right? Okay. Well, P is the amount that we put in for each payment, right? In this problem, we're putting in $3,000 for our payments, right? So P is 3,000. And we're paying once a year. So, N being the periods within a year that we pay, N in this case is going to be 1, because we only pay one time in an entire year. Okay. T is going to be 40 years. That seems pretty obvious, right? Because T is the time that we're paying into it. And finally, R, the interest rate. Well, it's 8%. But remember, when using percents in these formulas, we have to convert that back to a decimal. So let's go ahead and write it out. 0.08. Cool. So, all that remains now is throwing this all together to solve that first question, right? How much would be in the account at the end of the 40 years? Cool, so let's do that. We've got 3,000 times 1 plus R is 0.08. Since n is 1, we don't have to worry about writing out that fraction, right? And we don't have to worry about writing it out as our exponent, because 1 times anything is whatever that thing was. So we're just left with 40 in our exponent. Subtract 1, divide all of this by 0.08. This is an ugly equation, I know. But when we go through and we do all the arithmetic, what we're left with is approximately $777,169 in that account. So at the end of these 40 years, paying $3,000 a year, this person's IRA has $777,168. My mistake, 169. Apologies. Now, how much of that was due to interest? Well, let's think about this. We're paying in $3,000 a year. And we do that for 40 years, right? So what we end up paying in is 3,000 times 40. If we take 3,000 times 40 out of this, all we're left with is the interest that's incurred onto that account. So let's do that. 3,000 times 40 is going to be 120,000. So we have 77169 minus 120,000. And what we're going to be left with is 657,169. This is how much interest paid into their IRA. In other words, at the time of retirement, this person's going to have $777,169 in their retirement account. And what they paid in to have this much money in their retirement account was $120,000. Yeah, $120,000. So the interest, the extra money, the money that they earned by putting this money into their IRA, that comes out to be $657,169. I'm getting an IRA soon now. Having said that, let's move on. Let's say now we want to go in the other direction. We know the amount that we want, we know what the rate is, and we know what the time limit's going to be. But we need to know how much the principal is going to be, how much the payment is going to be. And we also know the period of payment as well, obviously, right? Well, if we want to go the other direction like this, we're going to want to apply this formula. The variables all mean the same thing. So these are the payments, P. A is the end amount R is the interest rate, N is the number of periods, and T is the time that we're paying it over, the number of years. So using myself now as an example, because I'm curious about it, right? I want to know what these numbers are going to look like. If, by the time I'm 65, I want to have $1 million in an IRA, how much do I need to put in yearly? Well, that's in 34 years. Like I said, I want $1 million in my account. And to be conservative with our estimate, let's assume that I have an account that earns 7% interest. That's on the low end of IRAs. If that's the case, then the payment would be 34, my mistake, 1 million. Wow, started that off way wrong. 1 million. Moral of the story of that mistake, everyone makes mistakes. We get ahead of ourselves and miss what we're saying and doing. So, to start off with, I need to place my amount, $1 million, times the rate divided by the number of periods. Well, I want the payment to be yearly, so N here is still 1, and the rate is 7%, so that's 0.07. And all of this is divided by 1 plus 0.07 raised to the 34th power minus 1. After we do all of this arithmetic, we're going to find what the monthly payments I would have to put into this particular account to have $1 million when I retire at 65. And after all that arithmetic, we're going to find it's about $7,797. About. I'm rounding here. Literally half a year's salary for me. There's no way I'm going to make $1 million in that time frame. But cool. So this is how we work with annuities, right? What we just found was if I wanted to set up an annuity for a retirement plan, and that annuity gained a yearly interest of 7%, and I pay in once a year with the goal of having $1 million in that account after 34 years, we just calculated what the payment I'd have to put in is. All right, so it comes time to buy a car. You decide to buy this car, you're going to take out a car loan. But in the process, you realize, I don't know what the payments are going to be. I have no clue. How are you going to solve that? Well, you can start off by saying, two things. One, car payments are an annuity. So, you're going to pay a fixed amount with a fixed period of time in between each payment. Okay, so that's an annuity for sure. And you know that you're paying for it with a loan. That loan's going to have a particular interest rate. You also know how long you're going to be paying these off, right? So you're paying an annuity at a fixed rate over a fixed amount of time. And you're paying a loan that has some initial amount, L, whatever that initial loan amount is, at a fixed rate for a fixed amount of time. So these two equations you can set equal. Once you set them equal, you can solve for P, the payment. You run through it, do all the algebra. What we come to is that the payment on a car loan is going to be equal to the rate of the loan divided by whatever the period of payment is, the yearly periods, all right, times the initial loan amount, divided by 1 minus the quantity, 1 plus r divided by n again, all raised to the negative n times t power. So before I move on, I want to note something. This negative power, what does that mean? Well, anytime you take something and raise it to a negative power, that is the same thing as saying, I want to take that thing, raise it to the power, and I want to put that in the denominator. So what I mean is, imagine we have just some random number b. We raise it to the negative k power. That is equal to 1 over b to the k power. And that's all we're saying here. This whole thing, this little bit, is really 1 over 1 plus r to the n to the t. I know it's confusing. If you have any questions, by all means, please feel free to shoot me an email and ask. But this is how we're going to calculate the payment that we owe. Cool, let's use it. What we've got in this problem behind me is a situation where we go to the loan, we go to the dealership and we take out a loan for $15,000. And this car loan has an interest rate of 8% and it's for a total of 4 years. Now our goal here is to find out what our monthly payment is going to be. Seems pretty straightforward, right? So I've gone ahead and I've labeled what our variables are going to be equal to. Our initial loan amount is $15,000. The rate of our loan is 8%. The number of periods is 12. We're paying monthly, so 12 months in a year, n is equal to 12. And we're paying it for 4 years. So now all that's left is plugging it into this equation and solving it. So to do that, what we've got is our payment is equal to 0.08 divided by 12 times 15,000 divided by 1 minus 1 plus 0.08 divided by 12 raised to the negative 12 times 4. So when we work out all this arithmetic, we find that our loan payment is $366 a month. Okay, cool. Having said that, how much extra are we going to have to pay now to cover the interest? Let's find out. Since we're paying this monthly over 4 years, we're going to pay this amount 48 times, right? So, we are going to pay 366 times 48. This is going to come out to be a grand total of $17,568. That's how much we pay by the end of our loan agreement. If that's the case, then what we paid into the loan, what we paid into the interest is going to be the difference between this and the initial loan amount, right? Cool. So 17,568 minus 15,000 all comes out to be $2,568. That's how much extra we paid in interest. Roughly 17% of what our original loan amount was. Cool. Let's look at homes. Before we jump into this problem behind me, there are a couple of things I think I should explain first about buying a home. The first thing you should know is what a down payment is. A down payment is something that buyers are usually contractually required to put ahead of the loan. So what I mean is, using this example, we're going to go buy a house for $195,000. And the bank wants us to put 10% down. What that means, what that's asking us to do is to pay off 10% of the original cost of the house before the loan ever even happens. So we're going to take off 10% of this cost because we're paying it up front. Then the loan will be against whatever is left over. Having said that, that loan is what we're paying off. The mortgage is whatever's left over. So in our problem, what we've got is a home that is, like I said, $195,000. And the bank wants us to pay off 10% of the house of the home before we ever even get the loan. And it wants us to pay 2 points at closing. I'll explain what that is in a second. And this home, or this loan, is going to be for 30 years with a fixed mortgage rate. So what that means is our loan is going to be contractually for 30 years. We're going to have to pay 7.5% interest on that loan. That's going to be the rate. And we're paying this loan off monthly. So how are we going to solve this problem? Well, the first part we're going to solve is find out what that down payment is. That's pretty straightforward. We're going to take 10% and multiply the original cost of our home. Okay. So what the bank wants us to pay off up front is $19,500 out of pocket up front. Cool. This is the down payment. This is A. Now, for part B, we want to find out what the mortgage is. Well, the mortgage is what's going to be left over after we pay this. Okay, so we're going to take 195,000 and subtract 19,500 from that. What we're going to have is $175,500. This is the mortgage. Now this next part is a little strange. 2 points at closing. Personally, I've never actually understood why you pay the 2 points up front, or why you pay these points at closing. My assumption, my understanding, is that this is actually a convenience fee. This is something that you pay the lender, the lending agency, and like I said, I don't know why. I've never understood why you have to pay these points. But what it means is every point is 1%. So we're going to be paying 2% to whoever the lending agency is. It's just 2%. It doesn't go towards anything for us. It is just a cost that we have to pay at closing. So it's 2% of the mortgage. Like I said, every point is 1%. So, we're going to pay 0.02 times 175,500. We're going to pay this to the bank. That comes out to be $3,510. I just stepped on the cord. All right, so far what we've solved. We found out what our down payment is. That's part A. We found out what the mortgage is. That's part B. We found out what the points at closing is. That's part C. Now what's left? Let's find out what our monthly payment is. Now this problem that I've got up here, it reduces this a lot. It simplifies it a lot because a lot of lending agencies require you to pay some sort of insurance or pay into an account that helps you pay off property taxes, et cetera, et cetera, et cetera. There are a lot of other expenses that are oftentimes lumped in with whatever your monthly payment is. Having said that, the monthly payment on just the loan itself is what we're going to calculate here. So that's going to be the monthly payment on just the mortgage given our interest rate. So I'm going to erase all of this now. Except for this. All right, to solve this problem, to solve this last part of the problem, we want to revisit that last equation we were just talking about. A is equal to the loan times the rate over the period, all that divided by 1 minus 1 plus the rate divided by the period, raised to the negative period times time. We're going to come back to this equation. But we've already figured out what the mortgage is. This is the initial loan amount. So, L is equal to 175,000. We're paying this monthly, so N is going to be 12. Okay. The mortgage rate is 7.5%. So R is going to be equal to 0.075. And finally, it's over a 30-year period. So T is going to equal 30 years. Now it's just a matter of putting it all together. We just have to take these numbers, throw them into that equation. When we do that, we find that we have 175,500 times 0.075 divide 12. All of that divided by 1 minus 1 plus 0.075 divided by 12 raised to the 12 times 30, the negative 12 times 30. And when all is said and done, and we've worked through this arithmetic, what we're going to find is that this is about $1,277. That is the monthly payment that you owe on this mortgage. That's all I've got for y'all today. If you have any questions, by all means, please feel free to shoot me an email. But this is the general gist of everything that I've got for y'all. Mortgages, I can understand if you have some questions, so please feel free to shoot me an email. Having said that, have a good one, guys. All right, so before everybody goes, I just realized I made a mistake. In that very last problem, it's not $1,277, it's $1,227. I made a mistake in my arithmetic. So yeah, having said that, have a good one, guys.